Hi gentlemen, Mr. Novak here. Just doing a quick video on Exponential and just an application of Exponential, unfortunately, is the spread of viruses such as the COVID-19. You may have heard of language such as exponential growth and flattening the curves. So this is the current state of affairs in Australia. I could go to Victoria, but pretty much it's all happening in Victoria. And if we go back to 13th of July, that was last Monday when we started the term. It was about 183, and then of course it's been oscillating up and down. Now, if we assume that it's going to continue on an exponential growth, we can investigate that on our graphic calculator, a very powerful tool. So there we are. 183 is represented by X on the graph being 13th of July. And we have Tuesday, Wednesday, all the way till Friday, the 24th of July. And as you know, back in June, we of course had very low scores in Victoria. So we're going back now in June sometime. We're hovering around very few. So we can now plot those points on a Cartesian plane. And there we have it. And there we go. There's July the 13th at 183. We have another point here. Day 2 went up to 244. And we're going the other way. We had some other days. What we're hoping, or Dan Andrews and the healthies, that in actual fact, it's been going up and down, up and down, up and down. We're hoping that we've actually, you might have heard the language, flattening the curve, so we'll go in this direction rather than following the exponential. So, oops, before I go there, I'll just click on the graph, and this is the function that best, as you can see, fit the data that was collected. So there is the fact that we have 2 to the power x plus 30, so we have a shift to the left, so going that way, of 30 days. Currently suggesting that, unfortunately, we're not the doubling each day, but we're increasing by about 10%. That's 1.1 or 10% growth. And this is the dilation factor of 11.5. And so remember, day 0, July the 13th, first day back this term, was 183. So let's see if that function actually maps onto that number. So that's 11.5 was a dilation factor. Shift times. We are growing at the rate of 10%, 1.1, raised to the power, and that's what an exponential is. The x value is actually a power. And of course, we're looking at day 0, which was July the 13th. And we have the plus 30. Okay, I think I might, let's see if plus 30 gives us 183. Oops, don't forget, sometimes you need to press Control Enter. No, it must have been 29. So let's try that. And no, 29. Control Enter, and there's your 182. Of course, we are now into our second week, and we've got about 4 weeks to go before we can go back to normal school. So, in 4 weeks' time, we're looking at around about day 35. We're going to now change the. Remember, when you started, we were having 5 weeks. 5, 6 is a 30. I'll make it 30. So let's see. If it was to follow an exponential growth, then the number could be 3,000 per day. So that's why it's so important that we wear our mask so that we can actually, in fact, flatten the curve and not grow exponentially. The other thing I'd like to just quickly demonstrate is that, remember, as Mr. Rich Farragut said, the exponential has very few features. Basically, where it cuts the y-axis, that's really easy to find because that's when x equals 0. The other one is, of course, this asymptote, which we normally draw as a dotted line. And of course, it's a horizontal line, so it'll be given by the function y equals. So let's see. Remember, we've learned about transformation. So dilation is, there you go, that's 2. The one we're looking at was 11.5. As you can see, that's what's trying to do, is change the rate. Going the opposite way, of course, when it becomes negative, it does a reflection. So remember, the minus is a reflection in the x-axis. And then we can go back to normal. This is the doubling. Of course, fortunately, we're only doing 1.1 with regards to COVID-19. The H, we'll leave it at that, b equals 2, so that's b equals 3. As you say, it's an unusual dilation, but we're not going to worry too much about that this year. We're mostly focusing on A as a dilation. H, remember, is left or right. For instance, I had there plus 30, and as you can see, that's what it was doing, moving it to the left. And if we go negative 30, H, it goes to the right. And finally, if I take it back, and each of those, remember, has the asymptote moved at all? No. Let's try that again. No. So the asymptote doesn't change. The only time the azimuth changes, of course, is when K. There it is. So the asymptote in this case will be y equals 2, a horizontal line, y equals 2. If I go the other way, and then of course we have y equals negative 2. Remember, that point there is easily found by using menu trace, graph trace, jump to the blue line. There we go. And there it is, our point. Press enter. And when x equals 0, we have negative 1 because we moved it 2 units down. Remember, x would normally give you 1, but moving it 2 units down, we went to negative 1. So that's a really easy point to discover. However, the one that's really challenging is that x-intercept. That's what we'll be looking at in the next lesson. The challenge, of course, is that the function is an unusual function where the x variable is not actually a number, it's a exponent or index or power. And so we'll need to use a thing called logs. So hopefully that helps to you with regards to how the asymptote behaves. Remember, this has very few features, where it cuts the y-axis, asymptote, and then we do need to maybe find when it's where it cuts the x-axis, but not very often, only when the function is drawn below or the asymptote is below the y-axis. Have a good day with this lesson as per previous instruction. Continuing on with the exercise 5F.